Right, continuing our study of surface area and volume of prisms and adding cylinders in there, we are now on lesson 913. What if the bases are not rectangles? Because everything we've been dealing with so far has been just based on the cubes and the blocks that we've been working with in the first two lessons. So in lessons 911 and 912, you investigated volume, surface area, and special three-dimensional solids called prisms. Today you will explore different ways to find volume and surface area of a prism and a related solid called a cylinder. You will also consider what happens to volume of a prism or cylinder if it slants to one side or if it is enlarged proportionally. So in problem 9-28, we are to examine the three-dimensional solid below. And it asks us to, on graph paper, draw a net that when folded will create this solid. So you could do this on graph paper if you would like. You can see that you have a base that is 3 units by 4 units. So I would start with that on my graph paper. You have a 3 unit by 4 unit base, and if you wanted to shade it in to show this the base, or you could simply write base on there to know that this is what it's sitting on. And you have sides that are going to come up 2 units on each side. So you have sides that are going to fold up on each side here. Sides that are going to fold up on each side. So notice that it's 2 units high on each one of these. Okay. So the one thing we need to make sure that we include here is a top. So the top is exactly the same as the base, or exactly the same as the bottom, and it's going to need to be attached to one of these wings so that when we fold it, it will fold up on itself. So I'm just going to add an additional face over here that we could simply call the top. So if you want this on your lesson, then you could simply draw it like that. You could simply draw this figure on your paper and just indicate what the dimensions are. The dimensions are what are important here. And then you have another rectangle here. Sorry, my art is definitely not up to par right now. So this is a 2 by 4 rectangle. This is a 2 by 3 rectangle. Our base here was a 4 by 3. This is 2 by 3 here. This is 2 by 4. And this one is a 3 by 4 because it's another base. So it is definitely a whole lot prettier and neater to work with this on graph paper. So if you have some handy, then absolutely use that. Okay. So it says to draw a net. That when folded will create the solid. Compare your net with those of your teammates. Your teammates may have added the wings, another wing over here. They may have added the top along a different one of the wings. So there's definitely some different options here. Okay. Is there more than one possible net? Yes, there is, because you can add the sides to different heights. Y'all may have a better way to explain that. You can attach the top to a different one of the sides, maybe. The top can be attached to any of the sides. That may be one way to explain it, but please explain it in a way that makes sense to you. And it wants us to find the surface area and volume of the solid. Volume is usually going to be the easiest one to find here because we are simply finding the area of the base and then multiplying it times the height. So the area of our base here is a 3 by 4 rectangle, which has an area of 12. And there are 2 layers here. So 12 times 2 gives us our volume here, which ends up being 24 cubic units. Remember that volume is always in cubic units. Area, or surface area, is always going to be in square units. So previously we used the capital letter A to represent area, so we're just going to use capital SA to represent surface area. And again, make sure that you are including all of the surfaces, the top and the bottom, front and back, left and right. So if you have your net, then you can just find the area of each one of these parts. So here I have my top and bottom shown here, 12 and 12. Maybe it'll help if I zoom in. Okay, my front and back are 2 by 3 rectangular faces, so that's 6 and 6. And then my left and right are 2 by 4 rectangular faces, so that is 8 and 8. So for my total surface area, I'm simply adding these numbers together. So I have 8 and 12, 8 and 12, 6 and 6. I'm going to write that out so that we can see that we have all of the surfaces represented here. So we have 12 plus 12, and we have 8 plus 8, and we have 6 plus 6. So the 12 and the 12 are our top and bottom, that's 24. The 8 and the 8 are our left and right, that's 16, and the 6 and 6 are our front and our back is 12. So when we add all of these together, 20, 30, 40, 50, 52 units squared is what we get for our surface area. All right, so special prisms. Again, if I'm going too fast or if you miss something that I'm saying or if you don't understand, please rewind and watch again or post a question in the discussion board on Canvas or make a note of it and bring it to tutoring on Friday. All right, so special prisms. The prism in problem 928 is an example of a rectangular prism because its bases are rectangular. Similarly, the prism shown here is a triangular prism because the two congruent bases are triangular. Carefully draw the prism around your paper, which you don't need to do because this is your paper and it's already on there. One way to do this is to draw the two triangular bases first and then connect them with lines. Notice that the hidden edges are represented with the dashed lines. And this wants you to find the surface area of the triangular prism. Remember that the surface area includes the area of all surfaces, the sides and the bases. So notice that you have two triangular bases. So you have two triangles. And then you have three rectangular faces. Okay? So you have plus your three rectangles. Now all your rectangles are going to be different because the lengths of the sides of the triangle are different. So we have our triangle here. And to find the length of this hypotenuse, you can use the Pythagorean theorem. 3 squared plus 4 squared equals c squared. Or you may recognize that this is a Pythagorean triple. So this is a 3, 4, 5. So this edge is 5. So one of our rectangles is a 5 by 9. One of our rectangles is a 4 by 9. And one of our rectangles is a 3 by 9. Okay? So our triangles, we have two triangles. Okay? Our triangles are 4 by 3 triangles. And the area of a triangle is 1/2 times the base times the height, or 1/2 times 3 times 4. So we have this kind of shelled out. 2 times the area of one triangle. One triangle is 1/2 times base times height. So you can simplify this in a number of ways. You could find the area of one triangle and then double it. Or you could say, well, 2 times 1/2, those 2's are just going to cancel each other out. And then you just have 3 times 4, which is 12. However you want to do that, the bases together should total 12. So your rectangles. You have a 9 by 5 rectangle, and you have a 9 by 4 rectangle, and you have a 9 by 3. Oops, I forgot the plus there. 9 by 3 rectangle. Okay, so 9 times 5 is 45, 9 times 4 is 36, and 9 times 3 is 27. The last thing that we need to do is just add all of these together. 12 and 45, 40, 50, 57. Okay, and then 36 and 27, 30, 40, 50, 63. So then we just have 57 plus 63 to contend with. 50 and 60 is 110, and then 7 and 3 is another 10. So here we have a total of 120. Now on this one we did have units. This one is in centimeters. So this one is going to be in square centimeters. Remember, anytime you're doing surface area, you are working in square units. So the surface area here is 120 square centimeters. Okay? If you need to see it again, rewind it, pause it, do whatever you need to do to help yourself understand this. Ask questions. If you're confused, ask questions. We don't know you're confused unless you ask questions. Now, part C wants you to find the volume of the triangular prism. So we're looking at the same structure here. The height is 9, and each layer is a triangle. So this is just like the building. It's just like, was it Paul's Tower from the last? Yep, Paul's Tower from the last lesson. One layer here is the area of one triangle, and it is 9 centimeters high. So the area of one triangle times the height is what we're working with here. Anytime that you are finding the volume of anything, you're going to find the area of the base and multiply that times the height of the prism. Okay? So in our case here, our base is a triangle. And the area of our triangle, 1/2 times base times height. So there's the area of one base. Okay? 4 times 3 is 12. Half of that is 6. And we're multiplying that times the height of the prism, which in our case here is 9. So 6 times 9 then is 54. And we are working in centimeters. Volume is in cubic units. So 54 cubic centimeters for our volume. Now, does this method work for finding surface area and volume work on other prisms? For example, what if the bases are hexagonal, like the one shown below? Work with your team to find the surface area and volume of this hexagonal prism. Assume that the bases are regular hexagons with side length 4 inches. You will have a problem like this on the test, so please take good notes. Please be neat and clear in your notes so that you can use this on the test. So, just like we have done many times over, before you can find the surface area or volume, you're going to need to find the area of the base. This is a hexagon, so we have worked with hexagons in the past. We know that hexagons are made up of equilateral triangles, which works in our favor. The equilateral triangles, 60, 60, and 60, make it to where when we drop a height down in this triangle, we have a 30, 60, 90 triangle. I'll make this a little bit bigger for you. Okay? Now we are shown here that each edge of the hexagon is 4 inches, which means each of these sides is 4. So to find the area of the hexagon, we are first going to find the area of one triangle and then multiply it times 6 because there are 6 of them inside your hexagon. Okay? So half of our base is 2. This is a 30, 60, 90 triangle where the hypotenuse is always double the short leg, and the long leg, which is represented by the height of our triangle here, is √3 times the short leg. So our height here is 2√3. So the area of one triangle, 1/2 times base times height. Half of our base is 2 times our height of 2√3. Gives us 4√3 for one of these triangles. There are 6 of them, so times 6 gives us 24√3 for the area of the hexagon. Okay, so the hard part's behind us. Then to find the volume, we found the area of our base. All we need to do now is multiply that times the height. So for the volume, we just need the area of the base, which is 24√3, times the height of our prism, which is 7. So 7 times 24, 7 times 4 is 28, carry your 2. So 168 √3. Don't forget your √3. This is in volume, so you have cubic inches here. Our volume then is 168 √3 cubic inches. And yes, you could punch that into a calculator and get a decimal answer, but you would have to round it and then it would no longer be exact. Anytime you can leave an answer in exact form, you are the better for it. Okay, so surface area might be a little bit trickier, but not too much. You have the area of your hexagon, and there's 2 of them, a top and a bottom, okay? So you have your top and bottom, which is going to be 24√3 plus 24√3, which is going to be 48√3. The rest of them are rectangles, and each rectangle is a 7x4 rectangle. So that's one of these rectangular faces. How many are there? Well, there's 6, because this is a 6-sided base. Okay, so the lateral faces, those are called your lateral faces. There are 6 of your 7x4 rectangles. There are 6 of your 7x4 rectangles. 7 times 4 is 28. And 28 times 6. 8 times 6 is 48, carry 4. 12 and 4 is 16, so you have 168 here. Okay, so your lateral faces plus your top and your bottom gives you a total surface area here. These are not like terms, so you cannot add them together. So you can't combine them.